So valves, they're a very ancient thing, and this saxophone is absolutely covered in them. Now their job is to restrict, control or divert a flow of a fluid, for example air, water or a slurry, and they've been in existence for thousands of years, and they're pretty easy to make. As the name suggests, if you've got yourself a hole and a flap of material to cover that hole, you've got yourself a flap valve. But of course, like that, they have their limitations. I mean, you see them in things like bellows, but they have limitations, and of course the saxophone has improved on that limitations by using things like springs, metal backing plates and levers. And we can make a pretty cool valve using an O-ring and a spring. And I did exactly that by printing up these three components. The O-ring goes in the little recess there, the spring goes in that there. This is actually the valve. It's a bit like a poppet valve, but that's the actual valve plate. That goes in there like that, and then the whole thing fits together like that. And when you put it together, the whole thing works as a pretty successful valve. You blow down there, the air is free to move. You blow down there, the plate moves against the rubber and it becomes a blockage, and so a valve. Now I've used a plate, you could equally use a ball. Some would argue a ball is better. But the role of the spring is to keep the thing pressed against the rubber. So this is always closed unless we put a higher pressure in here. We could, of course, reverse that so the spring always kept it open, in which case if we pressed on the top it would act just like a valve in your car engine. So that really works quite nicely, but of course it's disappointing to me on a number of levels, and perhaps the first level is having to include that rubber O-ring, because what I find is when you use external parts like springs and O-rings, people always say, where did you get it from? What's the exact specification? I can't find it. How on earth am I going to use this? And so generally sharing things, I think that's a disappointment, and it makes me think, okay, how can we replace those two parts so the whole thing would be 3D printed and you wouldn't need to search Amazon or whatever it is to find the bits that I've used? And the first thing I want to tackle is the O-ring. Now I want to do that because I've got this thing, which is the AD5X by Flashforge, and it's a multicolour printer. But in my case, of course, I'm using it as a multimedia printer. We've already used this in video 2353 where we made some bellows. We printed a sheath out of TPU, we overprinted that with PLA ribs, folded it up, we had some awesome bellows. This isn't nearly as much of a challenge actually. We print the base out of PLA and the top nice and soft and squishy for the valve to press against of TPU. Now people have said that TPU and PLA don't stick together. That's actually not true. They will stick as long as the surface is quite large. If you make it thin, they'll break away. But here we print the PLA at about 220 and we print the TPU at about 270, and that means the TPU melts a little bit into the PLA, forming a mechanical bond, and so we can print that easily on this. Now we don't need to use this obviously, we can just print two materials. You could print the base, you could print the TPU, you could glue the TPU onto the base and get the same effect. It's just mighty easy if all you do is set it up and wander away and make a cup of coffee. So how do we set that up? So here's our design in the Orca slicer provided with the AD5X. And you can see it's basically just a cylinder. There's a slight mark there. Let me zoom in. You see there's a little step right here between a top cylinder and bottom cylinder. That's actually kind of important later. Now on the setup of it, I've got two filaments, Flashforge PLA and Flashforge TPU. You could, of course, use different colours. Here the colour for me doesn't matter, but I've set one as red and one as yellow. And you click on the one or the two to set the colours, and you click the down to set the actual type of filament that you're going to use so that the slicer understands it. Now, it doesn't understand anything at the moment until we apply something to it. So if we click on the object, you'll notice this screen becomes live. And here we've got one called colour painting. If we change to colour painting, then we'll suddenly be able to paint our model with whatever we want, and there's a whole load of tool types to be able to do that. The easiest one I use is fill, and change to the filament type you want, and then we can just click on the area. That will change it to TPU, and here remember I talked about this little line. When it auto fills like that, it looks for edges. So I made the big one 38 millimeters and the small one 37.9 millimeters to create this little ledge. Now, that little ledge means all I have to do is click on it, and it'll change it to TPU, and the same on the inside, it'll change it to TPU. Then I can close the whole thing, and now it's set to TPU. All I have to do now is slice the plate and take it across to my printer. So to actually print it, of course, we put it onto the machine and press this button here, which is the print button, and it will pull up the models available to print. There's our disk that we want, and it's a choice of on the machine or it's actually on the USB. And it presents this screen. It's here, incidentally, where you delete things if you want to. You'll see a small next button. You press next, and here you'll see a mapping screen. So there are the filaments that I've got loaded. And if you've done in colour filament in PLA, you would have 4 of them in different colours. Here, this one, where we're showing the red and the yellow circles, they're the ones that I defined on the actual slicer itself. And I need to map them to the actual filaments. And you do that by highlighting it. So you just press it to highlight it. There we go. And then you would match it to whichever filament type is in 1, 2, 3 or 4. And you can see I've matched PLA to actual PLA, TPU to actual TPU. And then we just press the print button. And once it's printed, we get our base and our TPU squishy top, and we can pick that off, and there we go. That's part of our valve done. So here's our same valve bits. Pop the spring in there, pop the poppet in there. And then this time, this bit just goes in there like that. There we go. And we have a really good valve. So the AD5X did actually make that really easy, because all I did was print off this extra bit. The disappointing bit, and the bit that's much more difficult actually, is this bit here, the spring. And that's because of the way 3D printing works. So if I try to print this spring as is, it puts down the material in layers. So where it lifts up, there'll be a layer line that creates a weakness. If I try to print it that way around, it'll be even worse, because there'll be weakness all along there, and the spring will snap. Luckily, there are several kinds of springs that work really well as long as the filament is laid down in the direction of the spring. So you can make an extension or a compression spring that we used in the latch mechanism we made in video 2338, which looks a bit like a snake. And of course there are coil springs, which you see all over the place, where people are using them for their own clockwork. And then you have leaf springs that work really well, things like tweezers. But more importantly for us in this case, is this kind of spring. It's called an orthoplanar spring, and for us, it's very useful. So let's have a better look at it. Okay, it's printed, so those little bits there are the actual spring, and of course it's printed flat, so it doesn't have the weak snappy points. And if I press this down, what you should see is it's a spring in that direction. It's also a spring in that direction, so we can twist it and it will spring, or we can push it up and down and it will spring without having any weak points. And of course that's exactly what we want for our valve. So I took my orthoplanar spring and printed it in a little circle like that. Now we can take our case and we can put the orthoplanar spring in that case like that. Before we do that, however, we need to add the poppet, and the poppet this time has got a little ledge on it so that the orthoplanar spring is at the right height. We pop that spring on. There we go, like that. We can then drop it into our case. So we get our spring-loaded valve, and then we can take our TPU PLA bit and stick that on there, and we have our totally printed valve. Now I called this the very versatile valve because I think it is. I think it's versatile in the way that you go around making it, and also in the way that you use it. I mean, this, I printed it in TPU 95, you can get that down as far as printable versions at 30. If you don't like the TPU, you can leave it off and stick some soft rubber or other material on there. This bit here is for straight through, so it's got little holes here. If you don't like that, then you can close those off. and put the exit here. If you're worried about this bit sealing here, then obviously print a TPU section on the top of it that's completely encased, and then you're able to operate that with an actuator like a cam or maybe a solenoid. If you don't like the fact that this is normally closed, which it is, then if you move that case down a millimetre, it'll be normally open. So you can use it in many different ways. You can make it in many different ways. You don't have to control it because the spring's doing that job for you. Or you could control it with cams or actuators like solenoids to make a valve. I think that's really very adaptable and very useful, so I wanted to share it with you. Now, I will of course put these files on Thingiverse should anybody want them, but I hope you enjoyed the video, and thank you very much for watching. Please do remember to like and subscribe.